Hey, today I'm going to show you how to do electrostatics. So the first thing you have to memorize is that you have to know what to do if they give you, let's say they give you microcoulombs and when they give you nanocoulombs. So if they say, for instance, let's just say 6 microcoulombs. If they give you 6 microcoulombs, then you will say 6 times, you'll convert it to coulombs, so you'll say 6 times 10 to the power of negative 6. Right? If they give you 6 microcoulombs. And then if they give you 6 nanocoulombs, you will say 6 times 10 to the power of negative 9, right? So when you want to convert microcoulombs to coulombs, you say times 10 to the power of negative 6. If you want to convert nanocoulombs to coulombs, you say times 10 to the power of negative 9. This is the first thing you have to memorize. Another thing that you have to memorize is that if they give you a distance, let's just say 2 millimeters. So distance in physics is usually in meters. So if they give you millimeters, you have to convert it to meters. So to convert it to meters, you'll just say 2 times 10 to the power of negative 3. If they give you 2 centimeters, then you'll convert that to meters. So you'll say 2 times 10 to the power of negative 2. These are the things that you have to memorize. So you have to know how to change micro nanocoulombs into coulombs, and you have to know how to change centimeters and millimeters into meters. Just before I continue, if you want to be tutored, either online or physically, online it doesn't matter where you are or which country you are at, you can still be tutored. So we offer cheap online lessons, and if you want to be tutored physically, we can still make an arrangement. So call or WhatsApp this number, but preferably please WhatsApp this number, and then we will take it from there. So what I do is that I tutor people 5 days a week online, and I give tests once a week so that I can check your improvement. So another thing you need to know is that the force that is experienced by these two is the same, right? So it's the same force, right? If let's say there's an attraction force, when you look at this, there's actually an attraction force. This one is positive, this one is negative. So this one is attracting this one with a certain amount of force, and this one is also attracting this one with that same. So how do we calculate electrostatic force? We use Coulomb's law, which states that electrostatic force is equals to Coulomb's constant times the product of their charges. So Q1 times Q2. So this is the formula of R squared, right? So the electrostatic force is equals to this stuff. So whenever we want to calculate the electrostatic force experienced by each of them, we use this stuff. So let's say they want you to calculate the electrostatic force on Q1 due to Q2. But remember that the same, the electrostatic force on Q2 due to Q1 is the same, right? Because they're both exerting the same force of attraction. So let's say they want you to calculate the force, the electrostatic force on Q1 due to Q2. Alright, so before we do the calculations, let's first draw the free body diagram. So we have to draw the free body diagram on Q1 because the question says electrostatic force on Q1. So when it says on Q1 due to Q2, it's like on the force that Q1 is experiencing caused by Q2, right? So it says on Q1 due to Q2, so think of it as caused by Q2. So what is Q2 doing to Q1? So when they talk about Q1, you're drawing for Q1, but now you are not drawing according to what Q1 is doing. It says due to Q2, so it means caused by Q2. So you are drawing according to what is Q2 doing to Q1. So what is Q2 doing to Q1? Q2 is pulling Q1 towards its direction because it's an attractive force. So it's pulling Q1 towards it. So then this is the free body diagram. You have to learn it at this stage so that when I go to the higher level, you'll be able to do it. So basically, yes, Q1 is attracting Q2, right? Q1 is attracting Q2 towards it, right? But Q2 is also attracting Q1 towards it. So when the question says on Q1 due to Q2, you have to look at it as what is Q2 doing to Q1? That's what you have to look at it as. Q1 due to Q2, you look at it as what is Q2 doing to Q1. So Q2 is pulling Q1 towards its direction because it's an attractive force. If it was repelling force, it was going to be pushing Q1 away, hence it was going to be towards this direction. So what if the question says on Q2 due to Q1? So if it says on Q2 due to Q1, we have to draw the free body diagram now for Q2. Then we have to ask, what is Q1 doing to Q2? So on Q2 due to Q1. So what is Q1 doing to Q2? This is where a lot of people miss it. So what is Q1 doing to Q2? So Q1 is pulling Q2 towards it. So hence Q2 is experiencing this force because that is what is caused by Q1, right? So hence we're gonna say Q1 on Q2. But now the free body diagram I'm drawing is for Q1 due to Q2. So it means what is Q2 doing to Q1? So hence Q2 is pulling Q1 towards it. So hence we're gonna say Q2 on Q1, or F of Q2 due to Q1. Yeah, I can write it anyhow. So we already know that once we get our answer, the direction will be to the right. So we want to calculate the electrostatic force on Q1 due to Q2. So we're going to use the formula. So the electrostatic force is equals to, so Coulomb's constant is something that is in the formula sheet. So Coulomb's constant is 9,0 times 10 to the power of 9. So basically, when you practice, you'll know this by head. So it's in the formula sheet, right? And then now Q1, what is the charge? It's 6 nanocoulombs, but we're not supposed to leave it in nanocoulombs. We're supposed to convert it to coulombs. So how do we convert it from nano? From nano is times 10 to the power of negative 9. If it was micro, we would say times 10 to the power of negative 6. And then we don't consider the signs, right? Whether it's positive or negative. When we substitute into this formula, we don't consider the sign. So then this 5 times 10 to the power of negative 9 as well, because it's in nanocoulombs and we have to convert it to coulombs. And then now let's talk about the distance. So then it's over r squared, which is the distance, right? Now the distance is 2000 millimeters, as I put there, 2000 millimeters. So we can't leave it in millimeters. We have to convert it to meters. So in order to convert it to meters, we have to multiply it by 10 to the power of minus 3. And this is all squared. And then let's get the answer of this so you can verify with me. So the answer will be 6,75 times 10 to the power of minus 8. You can just verify if that is correct. But now with force, we don't have to get only magnitude. Force is a vector. We have to get magnitude and direction. So remember the direction, it was this was pulling this to the right because it's an attractive force. So therefore, we'll say to the right. Or we can even say attractive. It's still gonna be fine. But for now, I'm just gonna mention the direction because of the other levels. So to the right. What if we're calculating for Q2? If we're calculating the electrostatic force on Q2 due to Q1, meaning what is Q1 doing to Q2? So when we draw the free body diagram of Q2, we will draw a dot. So what is this thing doing to this? This is pulling this towards it, right? So Q1 is pulling Q2 towards it because it's an attractive force. Q2 is pulling Q1 towards it, but also Q1 is pulling Q2 towards it. But now when we say the electrostatic force on Q2 due to Q1 is like we're saying the electrostatic force on Q2 that is caused by Q1. So what is Q1 doing to Q2? So Q1 is pulling Q2 towards the left. So this will be the free body diagram. So then what does it mean? So if we're calculating for Q2, then it means that it would be to the left instead. So then the answer will be to the left. All right, here is another example. So let's look at this. So let's just say we have got 2 microcoulombs, right? And 1 microcoulombs and minus 3 microcoulombs. So now this time we're given in microcoulombs. So now let's call this Q1, Q2, and Q3. Now let's say that you are asked to calculate the net. Now we can talk of the net electrostatic force on Q1 experienced by the others. So now it's like the electrostatic force on Q1 that is caused by the other, right? So there is the electrostatic force on Q1 caused by Q2, and there is the electrostatic force on Q1 caused by Q3. That's why they say the net. So we have to find the result So we're going to calculate for both of them and we'll find the result. So first of all, I'm going to draw the free body diagram. So they say find the net electrostatic force on Q1 due to Q2 and Q3. Or they can say find the net electrostatic force on Q1 caused by the others, right? Or due to the others. So I wrote down the question, find the net electrostatic force on Q1 due to Q2 and Q3. Or they can say find the net electrostatic force on Q1 due to the others. So what are the others doing to Q1? So let's draw a free body diagram for Q1. So I'm just gonna draw it here. Okay, so this is gonna be for Q1. So let's find out what is Q2 doing to Q1. So Q2 and Q1 are like charges, right? So it's an attractive force, positive and positive. So since it's attractive force, it means they are repelling each other, meaning that Q2 is pushing Q1 away because they're repelling each other, right? This one is pushing this one away, this one is also pushing this one away. So Q2 is pushing this one away. So since it's pushing it away, it means the force of Q2 on Q1 is away. And then what is Q3 doing to Q1? Because remember they said the force on Q1 due to Q2 and Q3. So what is Q1 experiencing that is caused by Q2 and Q3? So Q1 is experiencing a push away because of Q2, and Q3 and Q1 are unlike charges, so they attract. So it means that Q3 will be pulling Q1 towards it. So it's experiencing a pulling force because of Q3. So Q1 is pulling Q3 is pulling Q1 towards it, and Q1 is also pulling Q3 towards it. But now what we're interested in, because they said Q1 due to Q2 and Q3, so what is Q1 experiencing that is caused by Q2 and Q3? So Q1 is experiencing a pull because of the attraction force, right? But Q1 is experiencing a push away because of the repulsion force of this. So it's experiencing a pull, right, due to the attractive force of Q3. So Q3 on Q1. So what is Q3 doing to Q1? So hence this is what it is. So we can choose the direction as positive. I'm going to choose my right as positive. So I'm going to say right is positive. So then, of course, it means that we're going to have to subtract the forces at the end. So let's find the force. Let's find each. So first we're going to find Q2 on Q1, then we're going to find Q3 on Q2. All right, let's begin. So we have to find Q3 on Q1 and Q3 on Q2, I mean. Okay, not Q3 on Q2, I made a mistake here. Q3 on Q1, right? Because remember we've been checking what is this one doing to Q1 and what is this one doing to Q1 as well, right? The force experience on Q1 due to Q2 and Q3. So we have to find Q2 on Q1 and Q3 on Q1. Okay, so I read through it there. So now let's find Q2 and Q1 first. So then we'll use the formula. Okay, so we'll use the formula which says that F is equals to K Q1 Q2 over R squared. Okay, cool. So let's substitute. So of course K is 9,0 times 10 to the power of 9. And then this side, we have 2 microcoulombs. We have to convert it to coulombs. So remember, when you have micro, and the signs don't matter. When you have micro, we'll say times 10 to the power of minus 6. And then, so we're comparing Q1 and Q2. We're finding the electrostatic force between Q1 and Q2. So for Q2 is 1 times 10 to the power of minus 6. And then this all over the squared distance. So the thing here is that we have it in centimeters. We have to convert it to meters. So 2000 centimeters. So times 10 to the power of minus 2. Remember, centimeters, 10 to the power of minus 2. Millimeters, 10 to the power of minus 3. And then let's just find the answer of this. So you can just verify that with me. That should be 0,0000045. You can also put it in scientific notation. Yeah, so with Q1 and Q2, that's what it's going to be. So let me just write it over there, 0,0000045. Okay. So now we're done with Q2 and Q1. Now let's find the electrostatic force experienced by Q1 due to Q3, right? So Q1 and Q3. Now I'll show you something. For now, let's just calculate. So it's gonna be 9,0 times 10 to the power of 9, and then that's how we're gonna have. So the charge, so it's Q3 and Q1, right? So let me start with Q1. So Q1, 2 microcoulombs. So 2 microcoulombs is gonna be 2 times 10 to the power of -6 micro, -6, nano, -9. So, and then now when it comes to Q3, remember the sign does not matter, times 10 to the power of -6. Okay, now be careful when it comes to the distance. Notice the distance here. The distance between Q1 and Q3 is neither 2,000 centimeters nor 4,000 centimeters. It is the combined version of it, right? So it means the distance is gonna be 2,000 plus 4,000, which is 6,000, and it's in centimeters, so we have to convert it to meters. So from centimeters to meters is -2, from millimeters would be -3. So this is squared. Okay, so let's get the answer. You can verify that with me. So the answer will be 0,00, I believe 0,006015. Matter of fact, I believe it's 0. Okay, you can just verify that with me. Okay, so now we found the one of this one. So this is 0,000015. So now we have to get the net. It's just like net force, right? So it's also a vector. So now since we chose right as positive, our left is going to be negative. So to get the net electrostatic force, we're going to say it's 0,000015 minus, you can also put this in scientific notation, 0,000045, which should be equals to 0,0003. Yep, you can verify that with me. So it's gonna be negative, meaning that the left will win. So then we'll say negative. Then on the next line we'll say 0,0003 to the left. Alright, if you enjoyed this video, please like and subscribe, and tune in for part 2. I'll put it in the link of the description below. Part 2, I'm gonna deal with this stuff in right angle form, where we've got we've got them in this position. So I'll deal with that in part 2.